Question number 28. A light of a single wavelength is incident. Single wavelength lambda is incident normally on a double slit. The slit separation can be varied. Okay, slit separation D can be varied. A screen is placed at a fixed distance away from the slit. Okay, the screen and double slit are parallel. Okay, synchronous, and the bright interference fringes are formed on the screen. So everything is fine. Then, which graph best demonstrates or shows the variation of the separation x of the bright interference fringes with the slit separation A? Now, what is x? You already learned. X is nothing but the fringe width beta. Okay, and this is nothing but the distance between the screen and the double slit is capital D, and this is nothing but this small d, which you already learned. So therefore, what is the expression for beta? Beta is equal to lambda capital D divided by small d. Lambda is same one wavelength, capital D is constant, this is constant, so beta is inversely proportional to D. Beta is inversely proportional to D, right? Which of them will be correct? This definitely is incorrect. What does it tell you? It tells you when D is increasing, beta is also increasing. So this is not possible. When D is increasing, beta should be decreasing. What about here? When D is increasing, here instead of D I put A here, right? So if A is increasing, then beta should decrease. But you see, it is decreasing in this manner. Okay, here non-variation, that is, if you have a non-linear variation, then you should follow something like this over here. So A is the right option. So here also it's increasing, this also not correct, this also not correct. So therefore, so A is the right option. Okay.